In today's class, we will solve a few problem sums based on real numbers, LCM and HCF, which are of level 2. The first one says that if k lies between 1 and 25, including 1 and 25, then how many prime numbers are there which are of the form 6k plus 1? So the prime numbers that we need to find, they will have or they will maintain this format 6k plus 1, whereas k starts from 1 and k ends at 25. So now if we start putting the value of k from 1 till 25 by following this format 6k plus 1, then the numbers that we will get will be, so here we have put the value of k from 1 to 10, and the numbers that we have obtained are from 7 to 61, and the format is 6k plus 1. So if we look at the pattern, and even from this formula also, we can say one thing, or we can conclude that the difference between two consecutive numbers is 6. So this is the first 10 number, and if we add or keep on adding 6 with the previous number, then we will get rest of the numbers. So if the last number, the 10th number, is 61, then definitely the 11th number is going to be 67, then it will be 73, and then with 73 if we add 6, then it will be 679, and so on. This is the next 10 numbers, and we need to find 5 more, as the value of k is from 1 to 25. So rest 5 numbers will be, now among these 25 numbers, what we can see is 7, then 13, then 19. These three are prime numbers, 25 composite number, then 31, 37, 43 are prime numbers, 49 composite, 55 composite, then 61, then 67, 73, 79, these are prime numbers, then 85, 91 composite numbers, then 97, 103, 109, these three are prime numbers, then 115, 121 composite, and from the last 5 what we can say is 127, then 139, and also the last number 151. These three are prime, and 133 and 145 are composite numbers. So among these 25 numbers, if we count, then it will be 7, and here 6, 13 and 3, total 16 prime numbers we have. Now the next problem sum says that Mr. X bought 3 apples, 5 bananas and 7 custard apples for certain amount which is even. What could be the cost of apples, bananas and custard apples? From these given options we have to choose. Now 3 apples, okay, fine, and 5 bananas and 7 custard apples, and total cost of these fruits will be even in nature. Now if we assume that each apple costs x rupees, then he bought 3 apples, so total amount that he paid for apples will be 3x. Now if we assume that price or cost of each banana is y, and total bananas that he bought was 5, so 5y, 5 multiplied by y, will be the total cost that or total amount he paid for bananas. Similarly, cost of each custard apple, if it is z, then total amount that he paid for 7 custard apples will be 7z, and if we sum them up, then that will be the total amount for all these fruits that he paid while purchasing. Now that amount is even. Now if that amount is even, then the possibilities are that this 3x, this has to be even, this has to be even, and the third one has to be even. So when we add 3 even numbers, then that gives us an even number in result. Similarly, this is one scenario, and if two of them are odd and the third one is even, then also then the total amount could be even. So odd plus odd, suppose 5 plus 7, that could be 12, even number. 9 plus 13, that is 22, so that is an even number. So when we add two odd numbers, we know that that becomes even, and even plus even will be even. And this is the only two possibilities that we can apply if the total amount is even. Otherwise, suppose if one amount is odd and two amounts are even, then even plus even, and even plus odd, that will become odd. So that is not possible if all the amounts are odd for apples, bananas, and custard apples. So three odds means finally it will give us odd only, so that is also not possible. Now if we look at the options, then the first option where we have 357, forget about the values. So 357, since they are all of them are odd numbers, so that is not possible, because if we add them, then the finally that will be odd. Now the second option is two values are even and the middle it is written 25, that is odd. So if we add two even numbers, two even prices, then that will be even, and even plus odd, that will be odd. So that doesn't satisfy the condition that we have in the question. Now the third option, here again two prices are even and the third one is odd, so if we add them, then that will be again finally odd. And the fourth option, whatever the values are, since two values are odd, so if we add them, then that will be even, and one value is even, so finally when we will add these three values, that will be even. Now the next question is the HCF of two numbers obtained in three steps of division is 7, and the first three questions are 2, 4, 6 respectively. Find the numbers. Now if we remember the division method of finding HCF, then we know that we divide between two numbers. When we find HCF, then we divide the highest number by the lowest number. So in that case, highest number becomes the dividend and the lowest number becomes the divisor. Now if we assume that the numbers are A1 and suppose D1, and A1 is the highest number and D1 is the lowest number, A1 is greater than D1, so what we will do is we will divide A1 by D1, and then we will have some quotient, say quotient is Q1, so this will be D1 Q1, and as per the normal rule of division, when we will subtract these two values, there will be some remainder. And as per this the question, this division has been performed in three steps, and the three quotients values are given, so definitely in the first step there will be some remainder, and that remainder, if we assume that that remainder is D2, then what we do, then in the next step we will take the remainder as divisor, and we will take the divisor as dividend in the next step. So now when we will divide, this will be suppose our quotient Q2, and this will become D2 Q2, and after subtraction there will be three steps. So in this step also we are going to have remainder. So that remainder, if we assume that that remainder value is D3, then in the third step, then D3 will become the divisor, and D2, what we had as divisor in the previous step, that will become dividend in the next step or in this step. So when we will divide, we will have again another quotient, suppose that is Q3, and this value will be D3 Q3, and after subtraction this is suppose D4. Now here in this the division method of finding HCF, we had only three steps, and in this is going to be our final step, and in the final step, as per the rule of this division method, there will be no remainder. So there will be no remainder in this step, remainder value will be 0, and the divisor that we have in the final step, that becomes the HCF. So in this division method, as we have three steps, so here D3 is the divisor in the final step or in the third step. So D3, value of D3 is what I said is the HCF. So HCF is given and that is 7. So D3, value of D3 will be 7. Fine. If value of D3 is 7 and also the quotients values are given in all these three steps, 2, 4 and 6 respectively. So value of Q3 will be 6, value of Q2 will be 4, and value of Q1 is 2. So if D3 is 7 and Q3 is 6, then what will be then D2? So D3 is 7 since it is, and Q3 is 6. So, and there is no remainder. That means D3 Q3 will be equal to D2. So D2 will be D3 Q3. That means 7 multiplied by 6. So it will be 42. And what will be D1 then? D1 will be D2 Q2 plus D3, because this was the remainder in this step. So after subtracting D2 Q2 from D1, we obtain D3. So when we will add D3 with this, we will get D1. So it will be D2 Q2 plus D3. Now D2 is 42 and Q2 is 4. So it will be 42 multiplied by 4 plus D3. D3 is 7. So D1 will become 175. Now what about A1 then? D1 is what? D1 was the lowest number among those two numbers. That means we have already obtained the one of the numbers which is lowest, and we need to find the other number which is higher or highest. So A1 will be what? The same concept. So the value of A1 will be 392. That means the numbers, one number is 175 and the other number is 392. The next problem sum says that find the greatest 4-digit number which when divided by 18 and 12 leaves a remainder of 4 in each case. So that means the greatest 4-digit number that we are going to find, that is not completely divisible by 18 or 12, and when we divide, then in both the cases it leaves remainder which value is 4. That means from that number, if we subtract 4, the remainder part, then the number that we will get, that will be completely divisible by 18 and 12. So if a number which is completely divisible by 18 and 12, we can say that that number will be a multiple of 18 as well as 12. That means that number will be a common multiple of 18 and 12. But this time we are going to find the greatest 4-digit number. So first we will find LCM, least common multiple of 18 and 12, and then we will see that how we can reach to that greatest 4-digit number. So the LCM of 18 and 12 is 36, but it is only a 2-digit number, but we need to find 4-digit number, and that too the greatest 4-digit number. So what we have to do, we have to increase, we have to multiply this 36, we have to reach to the desired value or to our destination. Now if we multiply 36 by 10 directly, then the value we know it will be 10 times, so 360. 360 is a 3-digit number, that is even lower than that greatest 4-digit number. So what we can do is we will keep on increasing that value. So by 20 if we multiply, then it will be 720. Okay, now 360 if we multiply by 30, then that will be 1080. Now 1080 is a 4-digit number, but that is not greatest 4-digit number. And if from 1080 if we want to know that what will be the lowest 4-digit number, then that can be achieved this way, that 1080 from here if we subtract 36, then that is still not lowest 4-digit number. So if we subtract one more 36, means 72 if we subtract, then that will become 1008. That means 36 when it will be multiplied by 28, then that gives us 1008, which is the lowest 4-digit number which will be divisible by 18 and 12. Now we need to find highest 4-digit number. So 36, now suppose if we multiply by 280, say 280 means again 10 times, so it will become 1008 and then one more 0 here. So this is 5-digit number, but which is slightly more than the greatest 4-digit number. So what we have to do, again what we have to do is we will apply the trick that we have applied here to get the lowest 4-digit number. And this time, this is the from here what we can do, we can first find the lowest 5-digit number. So again we have to subtract 36 twice. So if we do that, then this number will become 100 and then 08. That means we are subtracting 72, 36 twice. So we can say that when we multiply 36 by 278, then that value becomes 10008, but still it is a 5-digit number. And from here, if we subtract one more 36, then that will become 4-digit number, as well as that will be the greatest 4-digit number, which will be divisible by 18 and 12. And this is one of the ways how we can solve our thing. So that means finally 36, when it will be multiplied by 277, we are subtracting one more 36, so that value will become 9972. So 9972 is the greatest 4-digit number which is divisible by 18 as well as 12. But our question was slightly different. We have to find that greatest 4-digit number which when will it will be divided by 18 and 12. In both the cases it will leave a remainder whose value is 4. That means this is not the desired number, this is completely divisible, but we need to find a number which will be 4 more than this number which was completely divisible. Our desired number, or the number that as per this question that we are going to find, that number is 9976. Now let's move on to the next problem sum. It says that if m is prime and n is a composite number and m plus n is 240, and also their LCM, that value is given as 4199, then find m and n. M is prime and n is composite. Suppose the value of n is 3 and value of n is 12. 3 is prime, 12 is composite. Then what will be their HCF? Their HCF will be 3, right? Now suppose we have again the same number, first number prime number 3, and the second number is 8, which is a composite number. And what will be their HCF then? Between these two numbers there is no common divisor except 1. So the highest common factor will be 1 only. That means if we have a prime number and if we have a composite number, then there are two possibilities to have HCF. The first one is 1 if the other number, if the composite number is not a multiple of the prime number. And the second possibility, if the other number, the composite number, if it is a multiple of the first number which is prime, then the HCF will be the prime number itself. So there are two possibilities. Now we will go by the problem statement. Here the LCM value is given, and we know that if we multiply LCM by its HCF, then that will be actually the multiplication of both the numbers. So here this time mn. Now LCM value is 4199 and HCF value, if we take the first scenario, then the HCF is what? HCF is the first number, the prime number itself. That means it will be m and their multiplication, that will be equal to their multiplication. So m will cancel each other. That means the other number, the composite number will be 4199. But here we have another relationship between these two numbers. Their addition, the value of their addition is 240, that value. So if m is 3 and n is 4199, then this doesn't satisfy this equation, this relationship 240. That means the first scenario is not applicable. Now if we go by the second scenario, where their LCM value is 4199 and their HCF value is 1, and that will be equal to their multiplication result. So from here what we can obtain is that value of mn will be 4199. So from here we can say m will be 240 minus n, right? And if we put this value of m, or if we replace m in terms of n, so value in place of m we can write 240 minus n, and when it will be multiplied by the composite number, the second number n, then that will be equal to 4199. So now if we simplify further, then it will be 240n minus n square, and then that will be equal to 4199. If we rearrange the terms, then it will be n square, the quadratic equation of n. So if we take minus n square to the right side, then that will become plus n square. So n square and 240n, if we take to the other side, the right side, then it will become minus 240n, and then already we have 4199 on the right side, and that will become 0. The general format of the quadratic equation is ax square plus bx plus c is equal to 0. Here x is the variable, and in our case the n is the variable. But the coefficients value will be, a will be equal to 1, as in our equation it is only n square. So coefficient is 1. So value of a is 1. Value of b is how much? Value of b is minus 240, and value of c is 4199. Now if we solve this quadratic equation by the formula that we know, then it will be, we know that value of x, in our case it is n, it will be minus b plus minus root over b square minus 4ac and whole divided by 2a. This is the formula. So in our case, the value of b is minus 240, and here we have minus already. So this will become 240, then plus minus, and within the square root, then it will be minus 240 square, then minus 4. Value of a is what? 1, and value of c is 4199, and then whole divided by 2a. A is 1, that means this will be 2 only. And if we simplify this, definitely we are going to have two roots or two values of n, and in one of the equation, in one of the value we will have this plus sign, and in the other value or the value of the other root, second root, we'll have, where we'll consider this minus sign. Now if we separately complete this calculation, as I don't have enough space here, so the value of n for the first case, when we will consider plus sign, so 240 plus, and within this square root, whatever will be our final value after this calculation, and then that thing will be divided by 2. So if we complete that calculation, then that value will be 221, and the second value of n, where we will consider the negative sign, so 240 minus, and then the same value within square root, the same calculation, divided by 2, and that value will be 19. So we have obtained here two values of n, and n is what? As per our assumption and as per the question, n is the second number which is composite in nature, but 19 is a prime number. That means the value of n cannot be 19, and 221, it is a composite number. So the value of n will be 221, and if we subtract this value 221 from 240, then the other number which is prime in nature, that will be 19. Now the next one and the last one is find HCF and LCM of 100 and 101. Between 100 and 101, there is no common factor, there is no common divisor. So if we take the HCF, only common divisor will be 1, and that has to be the highest common divisor or highest common factor or greatest common divisor. So HCF of these two numbers will be 1, and since there is no common factor or common divisor, then LCM will be what? LCM will be simply multiplication of these two numbers. That means it will be 101, then 2 more zeros after that. So I hope you understood the solution of the given problems well, and with that hope I end today's class. Stay safe and stay healthy. Thank you.